Good morning, good afternoon, or good evening, whatever time you're watching this educational video. Thank you, by the way, for choosing this video as your guide in studying your physics concepts. All right, so we will be knowing the distinction between systematic and random error today, or at this particular moment. These two errors are very important, especially during experimentations. So we have this what we call experimental uncertainty. And like what I always say, that we cannot really achieve a perfect measurement if ever we're measuring something because of some conditions. So we have this two experimental not experimental uncertainty, but the causes of this uncertainty. We have systematic and random errors. Let's know the difference between the two errors. Let's have a random error can be obtained in measuring dimensions. For example, random errors are errors caused by unpredictable, uncontrollable changes in the experiment, such as in condition or the apparatus itself. There is a probability of the measurement being too high or too low, and then it spreads out results due to unpredictable situations. Situations changes uncontrollably, and it will generate a different result. So the result is spread out. And remember, when the results are spread out, it signifies that there's random error going on in that method or during the measurement. And then it cannot be eliminated, but can be reduced. And how it will be reduced? You will have to do it again and again, repeatedly, and then you will get the average. Or simply take note on this, you have to use precise apparatus in order to have or to avoid having these random errors. Sample of random errors, like since we cannot control it, changes in the environment during experimentation, especially if you don't need heat uh, or high temperature, but um, your setup there in your laboratory is, temperature there is usually hot, so it will overestimate the result, or yeah, the result of your experiment, if that's the case. Or um, you need you need this average temperature when conducting certain experiment, but then again the weather changes uncontrollably, yeah, unpredictable. Or even your hands, like when you're doing the measuring, and then your hands are trembling or shaking, you cannot control that kind of thing. So yeah, that will lead to random errors. Okay, or the spread of the results. And of course, misinterpreting the reading. When you're reading the measurement, it's like somehow you're looking at the calibrations of beakers or calibrated laboratory, let's say, flask. So yeah, you misinterpret the reading, so it will generate error randomly. And if you have insufficient data, meaning that data is done once, not repeatedly, so yeah, for sure it will have sort of random errors. Okay. On the other hand, we have systematic error. It occurs as a result of the flaw in the experimental design or the apparatus miscalibration. You do the method in one direction, you do the experimentation, and then the design, the framework, the method itself uh, has something wrong with it, and then you produce that kind of you produce the results of it. So this will contain systematic error. In the very first place, there is a flaw, there is a mistake in the experimental design or the framework or the apparatus itself. You never uh, calibrated the apparatus correctly before conducting your method or experiment. And then it causes the measurement values to be consistently higher depending on a situation, or it underestimate, or it will have a lower value than the accurate one. And reproducible inaccuracies in one direction, because in the very first place you use the wrong method, the wrong design, and the miscalibrated apparatus, for example, so it will reproduce inaccuracies already. And another definition that I got from other reference, it says that it is a consistent mistake due to inappropriate method, and cannot be reduced by conducting repeated trials or repeat trials. Uh, Repeating trials can reduce the random error, but systematic error, it cannot be reduced by doing a lot of repeated experiments. Sample, we have the heat loss. Later on, I will have like a situation why heat loss is a classic example of systematic error. Losing a product gas in reaction, we cannot really deny the fact that gas likes to escape. So whatever we try to control our setup, still some gas can escape. So it will systematically, let's say, underestimate our experimentation, or you misread the the calibration. You read the top of the meniscus when measuring volume, and then you do it in one time, one real time. You never notice that, so it will generate consistent mistake along the way. And then you forgot to set the mass balance into zero. You never, calibrated it before you conduct that one way experiment, so it will generate, or yeah, it will over estimate your results there. All right. So going back to heat loss in enthalpy. In an ideal enthalpy experiment, let's say determining the enthalpy change of a reaction using a calorimeter, we assume that all the heat produced or absorbed by the reaction is transferred to the measured substance, usually water, right? However, in real world setups, especially in our um, setup in the laboratory, some heat escapes to the surrounding, like the air or the container, especially if the insulation isn't perfect at all, right? Uh, Calorimeters themselves absorb some heat, which doesn't get measured unless specifically corrected. For example, you have that you will use calorimeter constant. Okay, the material of the calorimeter, um, it absorbs already the heat. So yeah, that's already one of the thing that it's part of the system, and then you produce the result of that experiment. So not random, sorry, the systematic error suggests in this setup. And lastly, if you're using a metallic stirrer or thermometer, of course, when you're measuring the temperature, or even a lead, this act as heat sinks. They will really absorb the heat. So you will underestimate now the because of this method that we usually use at school. We never notice that our results is being underestimated because some of the heat energy is or was lost already during the conduct of the experiment. All right. So again, experimental uncertainty. We're not sure about our measurement if it's precise or accurate. Um, they are caused by random and systematic errors, and we cannot really avoid that one unless we do something to reduce them, to reduce the error. Random, from the word itself, random, it has different results or slightly different results. So the results sometimes are being spread out or widely spread. So if it that's the case, the results or the measurements are different from each other, and therefore it lowers our precision. Systematic, on the other hand, it has a consistent results, but unfortunately not accurate, not correct, or away from our accepted value. So it lowers our accuracy. So I have a picture. I got this on the textbook, and it's here. Two types of error. We have systematic. It affects accuracy. It affects accuracy because your result is consistent, but it's not the accurate value because of this error. Measurement is too high or low, depending on the following: instrument not calibrated before the conduct of the experiment, faulty apparatus, incorrect measurement, imperfect instrument, procedure or method, incorrect. And it is predictable. That's the thing, it is predictable. And the direction of our systematic error one side, always one side. It could be generating a higher value, a higher results of your measurements, or lower results of your measurement. And it can be identified, yeah, because it's predictable. It can be identified. What's the reason? Or we can eliminate or reduce it by the following: improve measuring technique, like the example a while ago. You have to read the volume of the water in a calibrated apparatus well, not the top of that meniscus. Okay, and then you will have to calibrate equipment from for zero error. Okay, before you will weigh certain matter or substance, you have to calibrate your balance apparatus or your weighing scale into zero, and improve the design. If the method is wrong, it will generate wrong results, right? And if you notice that, so you have to change your framework, you have to change your design in order for you to have less systematic error. And in example, a heating experiment, like you only have one Bunsen burner, or let's say one source of your the gas stove, I guess, gas stove or electrical gas stove, and then you're heating different solutions there. When you measure the time before the solution to boil in just one electrical stove, I'm sorry for the term earlier, it's electrical stove, not electrical gas stove. I'm very sorry. And then you will put the solution there and then measure the time it will boil, and then you will remove it, you will put another solution and measure it directly without letting that electric stove to cool down. Unless you have a lot of electric stoves with you, you can definitely have or you will lower the systematic error that you will get from that setup. Okay, random error, it affects precision. The you know because it has random results or spread results, so precision is being affected. Measurement random, it will happen. You will generate random errors if instruments are imprecise, or yeah. And then fluctuation reading of the pipette or burette, like the angle that your eyes is observing is causing the error. Okay, small sample size or trials, like uh, w- an experiment done once without repeating it, so it will, of course, it has random errors. And then always remember, you can reduce it by having several trials. The more the better, you will get the average. And then statistical fluctuation or changing of you know statistics of your measurement, or reading by someone in incorrect reading of uh, measurements or calibrations, and they are unpredictable because it, sometimes we cannot control weather condition, we cannot control our physical response, like the shaking of our hands or like the sudden blink of our eyes that causes this error to happen. And then it's always random. It generates several and away from the accepted value sometimes. And then it can be reduced by using a precise instrument, and then or repeating more trials and get the average. Okay. Um, in most of the questions that I've encountered before, when are we going to reduce random error? So by replacing a more precise instrument, it will definitely reduce random error. Okay, and try out the same experiments again and again and get the average of that result. All right. So I hope this video will help you review the concepts about these two types of errors. And thank you so much. And I hope you will like and subscribe this video, educational video. That's it for today. Tomorrow, I mean, sorry, today, um, this afternoon, or that's it for this afternoon. That's it for tonight. It depends upon what time you're watching. Thank you so much. See you on another video.